Hello friends, welcome to the series of lectures of Mathematics 1. Myself Hardik Patel from LJ Institute of Engineering and Technology. Up to last session, we have seen the basic concepts of Fourier series, such as a Fourier series with a period 2 pi, discontinuous function, and now we are going to start with a change of interval. So today's topic is a change of interval. Fourier series with a function has a period 2L is in general we have, if we are starting with a Fourier series, then it is given by f of x is a function with a period 2L and interval is from c to c plus 2L. Then the Fourier series of a function is given by a0 by 2 plus sigma n running from 1 to infinity an cos n pi x upon L plus bn sin n pi x upon L. Correct? Now, where a0 is nothing but it is given by 1 upon L c to c plus 2L fx dx. Same manner, an is given by 1 upon L c to c plus 2L fx into cos n pi x upon L dx. And bn is 1 upon L c to c plus 2L fx into sin n pi x upon L, n pi x upon L dx. Correct? So, this is your Fourier series that we have already discussed. Up to last session, we have seen the Fourier series where L is equal to pi, correct? Now, instead of pi, if you have you have any value other than L, other than pi, then in that case, we are going to use this formula, and that is called the change of interval. Now, first of all, obtain the Fourier series of a function fx is equal to pi x for 0 less than x less than 1 and is equal to pi into 2 minus x for 1 is less than x is less than 2. That means you have p is equal to 2l is equal to 2. So that means you have l is equal to 1. Correct? And if you are not given this, then also from this interval you can have 2 minus 0 because total interval is from 0 to 2. So 2 minus 0 is equal to 2l. That means you have l is equal to 1. Correct? So if you are going to start with a solution, then first of all, the Fourier series is given by fx is equal to a0 by 2 plus sigma n running from 1 to infinity an into cos n pi x upon L. But L has a value 1, so it is cos n pi x. Same manner plus bn into sin n pi x, where a0 is given by 1 upon L, that is 1 upon 1, integration from 0 to 2 fx dx. But integration is going to be divided into two parts. First one is from 0 to 1 and second one is from 1 to 2. For 0 to 1 function has a value pi into x and for 1 to 2 function has a value 2 pi minus pi x. So if you are going to integrate it, then you will have pi x square by 2 and it has a limit from 0 to 1. And this has an integration 2 pi x minus pi x square by 2, which has a limit from 1 to 2. Now, substitute the upper limit and lower limit. That will give you pi by 2 minus 0 plus 4 pi minus 2 pi minus 2 pi minus pi by 2. And if you are going to simplify this, then you will have pi by 2 plus 2 pi minus 2 pi plus pi by 2. That means minus 2 pi plus 2 pi will be cancelled out and you will have answer pi. So a0 has a value pi. Now we are going with a an. An has a formula 1 upon L c to c plus 2L. So L is 1 and c to c plus 2L, that is your interval of integration, which is nothing but interval of function, that is from 0 to 2. So 1 upon 1 integration from 0 to 2 fx into cos n pi x upon L. L has a value 1, so it is cos n pi x dx. Now again break your integration in two parts. From 0 to 1 function has a value pi x and from 1 to 2 function has a value 2 pi minus pi x. Correct? Now using integration by parts. So first pi x as it is. That means we are going to use the continuous integration by parts. So pi x as it is and cos as an integration sin n pi x upon n pi minus pi x as a derivative pi. And this term sin n pi x upon n pi has a second integration minus cos n pi x upon n square pi square. correct? Then pi has a derivative 0, so we have these two terms and limit is from 0 to 1. Same manner, here you are applying u into v, then 2 pi minus pi x as it is, cos as the integration sine n pi x upon n pi, minus derivative of this term that will be a minus pi, and again integration of this one that will be a minus cos n pi x upon n square pi square, where limit is from 1 to 2, correct? Now, if you are going to substitute the limits, upper limit and lower limit, then first of all simplify this term, that will give you pi x into sine n pi x upon n pi minus minus plus pi into cos n pi x upon n square pi square, limit is from 0 to 1. And here you have 2 pi minus pi x into sine n pi x upon n pi, and 3 times minus, that will give you minus into pi cos n pi x upon n square pi square, where limit is from 1 to 2. Substitute the upper limit and lower limit. So if you are going to put 1, then sine n pi has a value 0. Cos n pi has a value minus 1 raised to n. So you will have 0 plus pi into minus 1 raised to n upon n square pi square. Minus, if you are going to put the lower limit 0, then 0 into anything, that will be 0. And cos 0 has a value 1. So you will have 0 plus pi into 1 upon n square pi square. Plus, now if you are going to put 2, then 2 pi minus 2 pi, that will be 0. Minus pi into cos 2n pi. Cos 2n pi has a value 1. So you will have minus pi into 1 upon n square pi square. Minus lower limit, if you are going to put 1, then 2 pi minus pi, that will be pi into sine n pi. But sine n pi has a value 0. Minus pi into cos n pi. Cos n pi has a value minus 1 raised to n. So you will have 0 minus pi into minus 1 raised to n upon n square pi square. Simplify this term, that will give you pi cancel out, and here also pi cancel out, minus minus will be plus. So you will have 2 times minus 1 raised to n upon n square pi, minus these terms are going to be minus pi into 1 upon n square pi square minus pi upon n square pi square. Pi will be cancelled out. So you will have minus 2 upon n square into pi. 2 upon n square into pi common out. So that will give you the term an is equal to 2 upon n square pi into the bracket minus 1 raised to n minus 1. Okay. So this is the value of an. Same manner we are going with a bn. Again bn is 1 upon L c to c plus 2L fx into sine n pi x upon L dx. But L has a value 1 and your interval is from 0 to 2. So integration is from 0 to 2. So bn is going to be 1 upon 1, 0 to 2 fx into sine n pi x dx. Now break your integration. That will give you 1 upon 1 integration 0 to 1. At that time function has a value pi x into sine n pi x dx plus 1 to 2. At that time function has a value 2 pi minus pi x into sine n pi x dx. Now integrate by using integration by parts. So pi x as it is, sine has an integration minus cos n pi x upon n pi, minus pi x is the derivative pi, and minus cos is the integration minus sine n pi x upon n square pi square. And it has a limit from 0 to 1. Same manner here you are using integration by parts, then it will be a 2 pi minus pi x into sine has an integration minus cos n pi x upon n pi, minus derivative of this term, that will be a minus pi, and again integration of this term, so minus cos as an integration minus sine n pi x upon n square pi square. So limit is from 1 to 2. Now simplify these terms. So minus plus minus, that will be minus pi x into cos n pi x upon n pi, minus minus plus, so you will have plus pi into sine n pi x upon n square pi square. Limit is from 0 to 1. And here minus into n plus, that will be a minus of 2 pi minus pi x into cos n pi x upon n pi, minus minus minus, 3 times minus, that will be a minus pi into sine n pi x upon n square pi square. Now first if you are going to put 1, then here you have minus pi into cos n pi, and here you have sine n pi, but sine n pi has a value 0. Same manner if you are going to put 0, then this term is 0 and sine 0 is 0. And same manner in second term, if you are going to put 2, then this term is 0, cos 2n pi has a value 1, sin 2n pi has a value 0. Minus, if you are going to put the lower limit, then you will have cos n pi, that will be minus 1 raised to n, and sin n pi will be 0. So if you are going to put the limits, upper limits and lower limits, then you will have minus pi into minus 1 raised to n minus 1 raised to n upon n pi plus 0 minus minus 0 plus 0 plus minus 0 minus 0 minus bracket into the bracket minus pi into minus 1 raised to n upon n pi minus 0. So if you are going to put the values, then you will have minus pi into minus 1 raised to n upon n pi plus pi into minus 1 raised to n upon n pi. So minus plus will be cancelled out and you will have answer Bn is equal to 0. So this is the value of A0, An and Bn. So now substitute these values in a Fourier series that will give you the Fourier series fx is equal to A0 by 2 plus sigma An cos n pi x plus sigma Bn sin n pi x. So A0 by 2 will be pi by 2, okay, and plus sigma An is your 2 upon n square pi into the bracket minus 1 raised to n minus 1 into cos n pi x, and Bn will be 0. So if you are going to put the values of these terms, then first of all 2 by pi common out and then substitute n is equal to 1, n is equal to 2, n is equal to 3. That will give you the Fourier series pi by 2 plus 2 by pi into the bracket minus 2 into cos pi x upon 1 square minus 2 into cos 3 pi x upon 3 square minus 2 into cos 5 pi x upon 5 square minus so on so on so on. Minus 2 common out and you will have pi by 2 minus 4 upon pi cos pi x upon 1 square plus cos 3 pi x upon 3 square plus cos 5 pi x upon 5 square and so on. So this is the required Fourier series of a given function. Now we are going with a second example. Find the Fourier series with a period 3 to represent fx is equal to 2x minus x square in the range of 0 to 3. Okay. So we are starting with function fx is equal to 2x minus x square and interval is from 0 to 3. Correct? So if you are going to compare with a period, then 2l is equal to 3. That will give you l is equal to 3 by 2. Correct? Now, if you are going to put this value in a Fourier series, then fx is equal to a0 by 2 plus sigma n running from 1 to infinity an cos n pi x upon l. L is 3 by 2, so 1 upon l will be 2 by 3. So you will have an into cos 2n pi x by 3 plus bn into sin 2n pi x by 3. Correct? Now, where a0 is nothing but 1 upon l. So 1 upon 3 by 2 integration from 0 to 3 fx dx. That will be a 2 by 3 integration from 0 to 3 and function is 2x minus x square dx. Now integrate this function, that will be a 2 by 3 and 2x is the integration x square by 2, x as the integration x square by 2, x square as the integration x cube by 3, and substitute the upper limit and lower limit. That will give 2 by 3 into 9 minus 9 minus 0 minus 0, and that will give you the answer 0. So an as a value 0. Same manner, we are starting with a0 as a value 0, and now we are starting with an. An is 1 upon l, that will be a 2 by 3, and integration is from 0 to 3. Fx into cos n pi x upon l, but 1 upon l is 2 by 3, so it is 2n pi x upon 3. Now fx is a value 2x minus x square, so put it, so you will have 2 by 3 integration from 0 to 3, 2x minus x square into cos 2n pi x dx. Now substitute, use integration by parts. So first 2x minus x square as it is, cos as the integration sin 2n pi x by 3 divided by 2n pi by 3, coefficient of x, minus derivative of 2x minus x square, that will be a 2 minus 2x, and again integration of this one, that will be sin as an integration minus cos 2n pi x upon 3 divided by 2n pi by 3 the whole square. Then plus derivative of this term, that will be a minus 2, and again integration of this term, that will be a minus cos as an integration minus sin 2n pi x by 3 divided by 2n pi by 3 the whole cube. Now first simplify this term, and that will give you 2x minus x into, this is denominator's denominator 3 is going to numerator, so it is 3 sin 2n pi x by 3 divided by 2n pi, minus minus plus 2 minus 2x into the bracket, 3 square is 9 is going in numerator, so 9 into cos 2n pi x upon 4n square pi square. And here minus minus plus 2 into 27 sine 2n pi x upon 3 divided by 8n cube pi cube. Limit is from 0 to 3. Now first put upper limit and then put the lower limit. So if you are going to substitute 3, then 3 will be cancelled out and you will get sine 2n pi. Here you will get cos 2n pi. Here you will get sine 2n pi. And the terms of sine 2n pi are going to be 0. So you will have 0 plus 2 minus 2 into 3, that will be 6, into cos 2n pi has a value 1. So you will have 9 upon 4n square pi square. Sin 2n pi has a value 0. Minus, if you are going to put the lower limit 0, then sin 0 has a value 0. Cos 0 has a value 1. So 2 minus 0 into 9 upon 4n square pi square. Plus sin 0 has a value 0. So if you are going to simplify this, then you will have minus 36 upon 4 pi square n square. Minus 18 upon 4 pi square n square. So that will give you minus 54 upon 4 n square pi square. And if you are going to simplify, then you will get an is equal to minus 9 upon n square pi square. So this is the answer of an. Now we are going with a bn. So bn is 1 upon l 0 to c plus 2l fx into sin n pi x upon l. But l has a value 3 by 2. So 1 upon l has a value 2 by 3. And interval is from 0 to 3. So bn is going to be 2 by 3 integration from 0 to 3 fx into sine 2n pi x upon 3 dx. Now put the value of function, that will give you 2 by 3 integration from 0 to 3 2x minus x square into sine 2n pi x by 3. Now use integration by parts, that will give you 2 by 3 into the bracket 2x minus x square. Sine has an integration minus cos, so minus cos 2n pi x by 3 divided by 2n pi by 3. Minus derivative of 2x minus x square, that will be a 2 minus 2x. And minus cos has an integration minus sine 2n pi x upon 2n pi by 3 the whole square. Now again derivative of this term is minus 2 and minus sine has an integration minus cos, so minus minus plus, that will give you plus cos 2n pi x by 3 divided by 2n pi by 3 the whole cube. Simplify these terms and write down denominator to numerator. That will give you 2 by 3 into the bracket minus 2x minus x square into the bracket 3 minus cos 2n pi x by 3 divided by 2n pi plus minus minus plus, that will give you 2 minus 2x into another bracket 9 sine and 2n pi x by 3 divided by 4n square pi square minus 2 into 27 cos 2n pi x by 3 divided by 8n cube pi cube, and limit is from 0 to 3. So if you are going to put the limits, then sine 3n pi, if you are going to put 3, then 3 will be cancelled out. You will have cos 2n pi. Cos 2n pi has a value 1. So here you have 6 minus 9 into 3 upon 2n pi. This term will be 0. Here you have cos 2n pi, that has a value 1. So minus 2 into 27 upon 8n cube pi cube. Minus lower limit, if you are going to put 0, then this term will be 0. Sin n pi has a value 0. And cos n pi has a value 1. So minus 2 into 27 upon 8 n cube pi cube. Now put all simplify. So simplifying these terms, that will give you, if you are 2 by 3 into 9 upon 2 n pi minus 54 upon 8 n cube pi cube plus 54 upon 8 n cube pi cube. So minus and plus will be cancelled out and you will have 2 by 3 into 9 by 2 n pi. So simplifying this term, that will give you bn is equal to 3 upon n pi. Now substitute all these values a0, an and bn in a Fourier series. So we have the Fourier series fx is equal to a0 as a value 0. So plus sigma n running from 0 to infinity. An has a value minus 9 upon n square pi square cos 2n pi by 3 and plus bn has a value 3 upon n pi. So that will give you 3 upon n pi sine 2n pi x by 3. So simply separate the terms and write down in a simple form. That will give you minus 9 upon pi square into sigma n running from 1 to infinity 1 upon n square cos 2n pi x by 3 plus 3 upon pi sigma n running from 1 to infinity 1 upon n sine 2n pi x by 3. So Now, these are the some examples which you have to do yourself. If you have any doubts or any query regarding these topics, then please feel free to contact me. Thank you so much for watching me.